Okay, in this problem, you have 2 moles of a gas confined to a 5-liter vessel at a pressure of 8 atmospheres. I want the average kinetic energy of a molecule. So it looks like an ideal gas problem because I'm given like just the amount of gas and the pressure and the volume, right? But I need to get kinetic energy. So I'm going to have to use the relationship between kinetic energy and temperature. So kinetic energy is 1.5 times the number of molecules times Boltzmann's constant times the temperature, right? That's the average kinetic energy of a gas molecule, right? So I'm going to need to get temperature. Okay, so how can I get temperature? We can use the ideal gas law. So ideal gas law says PV equals nRT, right? And R is 8.31. The number of moles, 2 moles, right? So that's my N. T, I'm trying to find pressure is 8 atmospheres, right? So my pressure, I'm going to have to take 8 atmospheres and multiply it by 101,300 to turn it into pascals so that I can use this, right? So there's my pressure. And my volume is 5 liters. So again, my volume, it's 1,000 liters per cubic meter. So I have to take that and divide that number by 1,000, or move the decimal back 3 places, right? And then I can do this and I can solve for T. And once I get T, I can plug T in up here, right? And for this problem, when you're using this equation, N is the number of molecules, right? So I want the average kinetic energy of a gas molecule. So that means my N in this equation is going to be 1, right? So if I had multiple gas molecules, I could figure out the energy of a bunch of gas molecules, but I just want 1 gas molecule. So in this equation, my N is going to be 1. And it gives you Boltzmann's constant, and so you can solve for kinetic energy. But it involves ideal gas law first, and then use the relationship between temperature and kinetic energy.